Hello students, after completion of preparation and properties of amines, now let us study another class of nitrogen containing compounds, that is diazonium salts, aryl diazonium salts or arene diazonium salts. So these compounds are very much synthetic applications than that of alkyl halide and Grignard's reagent. These are also, you can say, these are also some reaction intermediates. So these compounds are named after writing by adding a suffix diazonium to the parent hydrocarbon followed by the name of anion. So how to name? First hydrocarbon part plus diazonium, the suffix, then name of anion. These are salt. So this consists of two parts, a positive part cation and a negative part anion. Look at some example. This is benzene, diazonium and chloride. Benzene, diazonium, chloride. Similarly, N plus, Br minus, benzene, diazonium, bromide. Similarly, N plus H, SO4 minus, benzene, diazonium, hydrogen sulfate. This is the hydrogen sulfate, diazonium, benzene. Similarly, benzene, diazonium, tetrafluoroborate. Okay, so in this way these are named. Next come to its preparation. So specially here we will study about benzene diazonium chloride. So this benzene diazonium chloride is prepared by the method called diazotization. Preparation. By this method is known as diazotization. So when aniline reacts with nitrous acid, at 273 to 278 Kelvin at ice cold temperature, we can say ice cold temperature, then it forms benzene diazonium chloride. Okay, this reaction takes place in some acid medium. Actually, you know, this nitrous acid is unstable. It is prepared at the time of requirement. So in this way, we can write here NaNO2 plus HCl. Actually, this reaction takes place in presence of more amount of HCl and less amount of nitrous acid. Okay, so aniline. In short, to this benzene diazonium chloride, I am writing here BDC, benzene diazonium chloride. Actually, how this reaction takes place? First, this aniline treated with ice at ice cold temperature. This aniline treated with HCl to form anilinium hydrochloride. Anilinium hydrochloride or anilinium chloride, and this and again sodium nitrite reacts with HCl to form sodium nitrite reacts with HCl to form sodium chloride plus HONO or nitrous acid, and then again this takes place at ice cold temperature, at low temperature 273 to 278 Kelvin. Again these are treated with C6H5 NH3 plus Cl minus plus HONO give rise to C6H5 N2 plus Cl minus and N2 plus Cl minus plus 2H2O. Okay, so we can write the reaction like this, or here also we can write H2O plus NaCl. One product is here NaCl, so I am writing NaCl. Okay. So aniline reacts with nitrous acid. In present, nitrous acid at ice cold temperature. Temperature is maintained 273 to 278 Kelvin at ice cold temperature to form benzene diazonium chloride. This reaction is known as diazotization. So you can write in one step or in three-step reaction. Okay. So next come to properties. So these compounds are stable compound. These are actually less stable compounds. If we compare aliphatic and aromatic, between aliphatic and aromatic, the aliphatic diazonium salts are less stable, while aromatic diazonium salts are stable to some extent, and these are generally used for synthesis of different products. And these are white crystalline salts soluble in water. These are white crystalline salts soluble in water, and their aqueous solution conduct electricity. So although these are stable, but their lifetime is short. So in this way, it is also, the diazonium salt is also prepared at the time of requirement, and this is used for the synthesis of various compounds. And the reaction of this diazonium salt generally involve two types. One type, reactions involving replacement of diazonium group. So in this case, the diazonium group is replaced and another monovalent atom or group is substituted. And another, reactions involving retention of diazonium group. So two types of reactions. First, let us discuss the reaction involving replacement of diazonium group, in which diazonium group is replaced by evolution of nitrogen gas, and some groups, monovalent groups, are substituted at that place. So reactions involving replacement of diazonium group. First, replacement by hydrogen. replacement by hydrogen. So when this benzene diazonium chloride reacts with hypophosphorus acid in presence of a cuprous salt, then it forms benzene and the diazono group is replaced by hydrogen. Look here, N plus Cl minus, this is benzene diazonium chloride, H3PO2 water in presence of a cuprous salt such as cuprous chloride, it gives. So this group is replaced by hydrogen. So it gives, actually this compound is reduced and this compound is oxidized. So it gives benzene, hydrogen is substituted in place of this, plus N2 plus HCl plus H3PO3. Okay, so replaced by hydrogen. This reaction also takes place when this benzene diazonium chloride treated with ethanol. So this compound, when treated with ethanol, it also forms benzene. Look at the equation. So when benzene diazonium chloride treated with ethanol, it forms benzene plus N2 plus HCl and CH3CHO. This ethanol undergo oxidation to aldehyde. This nitrogen is removed here, diazo group, and Cl minus converted to HCl. So it forms benzene. So benzene diazonium chloride, when treated with hypophosphorus acid, aqueous solution of hypophosphorus acid in presence of cuprous salt, it forms benzene. Or when benzene diazonium chloride treated with ethanol, it also forms benzene by replacing this diazonium group with hydrogen. Next, come to replacement by halogen. So halogens, X. There are different types of reactions for different halogens. First, when benzene diazonium chloride N plus and Cl minus. When benzene diazonium chloride treated with cuprous chloride in presence of HCl or cuprous bromide in presence of HBr, then it forms chlorobenzene and bromobenzene. This group is replaced by chlorine and bromine. This reaction is known as Sandmeyer's reaction. So, when this is treated with CuCl, cuprous in presence of HCl, or it forms CuBr in presence of HBr, then it forms chlorobenzene plus N2, and here also bromobenzene plus N2 plus CuCl. Bromine is substituted here and this Cl is removed as CuCl, and here also chlorine is, and this chlorine is removed as CuCl. So this is benzene diazonium chloride. It forms chlorobenzene and bromobenzene. You know already this, I think this reaction is known as Sandmeyer's reaction. Sandmeyer's reaction. So this reaction is modified if we take, instead of copper chloride and copper bromide, if copper powder is taken in presence of HCl and copper powder is taken in presence of HBr, then also chlorobenzene and bromobenzene are formed, and this reaction is known as modified Sandmeyer's reaction or Gattermann reaction. Suppose we take copper in presence of HCl or copper in presence of HBr, then it also forms this chlorobenzene and bromobenzene. This reaction is known as modified Sandmeyer's reaction or known as Gattermann reaction. Modified Sandmeyer reaction or Gattermann reaction. Okay. Next, come to, so this is about chlorobenzene and bromobenzene. By CuCl in presence of HCl, CuBr in presence of HBr, or copper in presence of HCl and copper in presence of HBr. Next, come to another reaction, how iodobenzene is formed. So when this benzene diazonium chloride heated with potassium iodide, when this is heated with potassium iodide, okay, plus potassium iodide, and it is heated with potassium iodide, then it forms iodobenzene. This is iodobenzene plus N2 plus KCl. So when benzene diazonium chloride heated with potassium iodide, it forms iodobenzene. So chlorobenzene, bromobenzene, iodobenzene. Now come to fluorobenzene. So when this benzene diazonium chloride treated with hydrofluoroboric acid, when this is treated with hydrofluoroboric acid, it forms benzene diazonium tetrahydrofluoroborate N2 plus and BF4 minus. So this is benzene diazonium tetrafluoroborate. Benzene diazonium tetrafluoroborate. When benzene diazonium chloride treated with hydrofluoroboric acid, it forms benzene diazonium tetrafluoroborate, which on heating, so here minus HCl, which on heating forms fluorobenzene. It forms fluorobenzene plus nitrogen group plus BF3. These are the side product. So in this way, fluorine, chlorine, bromine, iodine are replaced but substituted by this diazonium group. Next, replacement by nitrite group. Replacement by NO2 for organic, that is your nitro group. Okay. So here benzene diazonium chloride when treated with benzene diazonium chloride when treated with hydrofluoroboric acid, first it forms N2 plus BF4 minus, that is your benzene diazonium tetrafluoroborate, which on treatment with aqueous solution of sodium nitrite, which when treated with aqueous solution of sodium nitrite, it forms nitrobenzene plus N2, this is nitrobenzene plus BF3 plus NF. So benzene diazonium chloride treated with hydrofluoroboric acid followed by treatment with sodium nitrite forms nitrobenzene. Okay. Next, replacement by cyanide group. So when this benzene diazonium chloride treated with cuprocyanide, when this is treated with cuprocyanide in presence of potassium cyanide, it forms cuprocyanide or potassium cyanide, it forms cyanobenzene. Benzene diazonium chloride treated with cuprocyanide, it forms cyanobenzene, and N2 plus CuCl. This reaction cyanobenzene, this reaction is also known as Sandmeyer's reaction. So benzene diazonium chloride when treated with cuprocyanide, it forms cyanobenzene. Instead of cuprocyanide, if it is taken copper, if copper is taken in presence of potassium cyanide, so if we take copper powder in presence of potassium cyanide, then also it forms cyanobenzene. So in this way replacement by cyano group. Next come to replacement by aryl group. So N plus NCl minus. So benzene diazonium chloride when treated with benzene, when this is treated with benzene in presence of sodium hydroxide, it forms diphenyl. It forms diphenyl or biphenyl. Plus N2 plus HCl. So here this group is substituted by this. This is benzene, and this reaction is known as Gomberg-Weizmann reaction. This reaction is known as Gomberg-Weizmann reaction. Next come to another reaction, replacement of OH group. replacement by OH group. So when benzene diazonium chloride aqueous solution of benzene diazonium chloride heated in acid medium, just warmed greater than 278 Kelvin or more than 10 degrees Celsius. So when benzene diazonium chloride, aqueous solution of benzene diazonium chloride in acid medium warmed, it forms phenol. So this group is replaced by OH plus N2 plus HCl. Okay. So these are the reaction in which the OH group, there is a reaction in which the diazonium group is replaced by some other groups like OH group, hydrogen, halogen, cyanide, etc. So this group is replaced. Now let us look or consider some other reaction where this diazo group is retained. Next come to another type of reaction. Already you know, I think, Ball-Schiemann reaction when benzene diazonium chloride treated with hydrofluoroboric acid, it forms benzene diazonium tetrafluoroborate, which on heating forms fluorobenzene. So the conversion of benzene diazonium chloride to fluorobenzene is known as Ball-Schiemann reaction. I think this name reaction you know. Okay, next come to chemical reactions which involve retention of diazo group. So this group is actually does not replaced or substituted. Okay. So first, reduction. When benzene diazonium chloride reduced with SnCl2 in presence of HCl or with sodium sulfide, then it forms phenyl hydrazine. This is N plus Cl minus. When this is reduced with either SnCl2 in presence of HCl or sodium sulfate, it forms NH2. So this azo group is retained, nitrogen is retained. It forms phenyl hydrazine. So plus HCl. So it undergoes benzene diazonium chloride. Benzene diazonium chloride when reduced with stannous chloride in presence of HCl, concentrated HCl or sodium sulfide, it undergo reduction to form phenyl hydrazine. But if the reaction takes place in presence of zinc and HCl, then complete reduction takes place and it forms aniline. Okay. But if the reaction takes place in presence of zinc and HCl, so when the reaction takes place in presence of zinc and HCl, it undergo reduction to form aniline. So here it forms aniline plus ammonium chloride. It forms aniline. Next, some other reaction where this group is retained. That is known as your coupling reaction. Coupling reaction. So benzene diazonium chloride when treated with phenol benzene diazonium chloride when treated with phenol in slightly alkaline medium pH 9 to 10, temperature 273 to 278 Kelvin. So when benzene diazonium chloride treated with phenol your Cl minus, your H, so it forms N double bond N OH. It forms para hydroxy azo benzene, which is an orange dye. So this group is written here. Okay. So when benzene diazonium chloride treated with phenol in alkaline medium, this is alkaline medium. So pH is 9 to 10 means alkaline medium. In alkaline medium, it forms para hydroxy azobenzene. These two groups are coupled, joined. This is called coupling reaction. And in the same way, also aniline reacts with benzene diazonium chloride. Okay, benzene diazonium chloride reacts with phenol in alkaline medium to form para hydroxy azobenzene and orange dye. Similarly, aniline reacts with benzene diazonium chloride in acid medium NH2. This is aniline. So benzene reacts with aniline in acid medium, minus HCl is there. So pH value, this is acidic medium, slightly acidic medium, 4 to 5. pH value 4 to 5. Temperature is also same, low temperature, that is 273 to 278 Kelvin. So minus HCl is there. First it forms N double bond N NH. This is an substituted product which on acid medium undergo rearrangement. It undergo rearrangement to form para amino azo benzene. This is an yellow dye. Okay, so benzene diazonium chloride reacts with aniline in acidic medium to form para amino azo benzene. Instead of writing this intermediate step, you can write directly BDC or benzene diazonium chloride reacts with aniline in acidic medium to form para-amino-azobenzene. So these two reactions are known as coupling reaction, in which this azo group is retained. Okay. So this compound has very much synthetic application. And what are the synthetic applications of this diazonium salt? We will discuss by some assignment.